So let's start with states of matter. Now, what is matter? Matter, what matter? I'm not asking about English matter. What is the matter in chemistry? So matter is what? Matter is anything which occupies space and has mass. Okay. So, what are the three states of matter? Matter, what is matter? Matter itself occupies space and mass, and you'll ask what is matter? Three states of matter. So, three states of matter are what? Solid, liquid, and gas. So, in this chapter, they will NCRT syllabus. They'll explain in detail about only about liquids and gases. They won't explain about solids, so don't break your head in going to solids. So we'll start with gas now. So gases. So what are gases? Gas means what? Matlab oxygen, carbon dioxide, anything it's an atmosphere, you'll say. But according to the chapter, we only prefer the characteristics of gases. So gases are what? Gases are they don't have shape and size like liquids or solids. So write the first one. Like start with the sentences. Gases have no shape and size. So what are other characteristics of gas? We use in perfume also. So what? When you spray perfume on your body, the entire room gets the smell of perfume. So what takes place? Diffusion takes place. So we write it as diffusion takes place easily. So what are other characteristics? Gases are highly compressible. So highly compressible. So these are the characteristics of gases. Now we'll go in detail. So who introduced these laws of gases? Or see, there are only three names. So in gas laws, there are three names. There is A, B, and C. Remember A, B, and C. So what is first one? A stands for Avogadro's law. Okay. Avogadro's law. B stands for Boyle's law. Boyle's law. And C stands for Charles' law. So when we apply all these three laws, we get a ideal gas equation. I'll explain you later part of the chapter. So when a gas obeys all these three laws, it's called ideal gas. When a gas does not obey these three laws, it's called a real gas. So I'll explain. First we'll go through all these laws now. So what is Boyle's law? Boyle's law, I'm studying from what, 7th class. Everyone knows what is Boyle's law. What is Boyle's law? Boyle's law is like temperature is constant. Temperature constant है. Pressure of a gas of a fixed mass of a gas is directly proportional to volume. See, in Boyle's law, pressure and volume are only taken. Temperature is kicked out. So, temperature is constant. We only consider pressure and volume. So, so what do you say? This Boyle's law equation is P1 V1 equal to P2 V2. Remember this equation for Boyle's law if you are solving any sum. So what is next law? Charles law. Charles law क्या है? No, Charles law is what? Charles law pressure constant होता है. Pressure is constant. Pressure constant, volume of a fixed mass of a gas is directly proportional to temperature. So V and T is proportional. Here pressure is kicked out, so pressure is constant. V1 divided by T1 equals V2 divided by T2. So in this P and V is partners. Here V and T are partners. Here T is kicked out, here P is kicked out. That's the common difference. Here T is kicked out in Boyle's law and P is kicked out in Charles' law. That's it. Your pressure is directly proportional to temperature. Your pressure is directly proportional to volume. In Avogadro's law, it's totally different. Avogadro's law. Avogadro's law states that volume of all gases under same condition contain equal number of molecule. So volume is directly proportional to N. So Boyle's law, what is this is equation for Avogadro's law. So we'll combine all this equation. First we'll write all this equation. So Boyle's law's equation, what is Boyle's law equation? V is directly proportional to V is directly proportional to P is directly proportional to V, and Charles' law pressure is kicked out, so V is directly V divided by T, and Avogadro's law, V is directly proportional to N. Avogadro's law. So now what is ideal gas equation? Ideal gas equation is anything gas which obeys Boyle's law, Charles' law, Avogadro's law. It's called ideal gas. Boyle's law, Charles' law, Avogadro's law. If a gas does not obey these three laws, it's called a real gas. Okay. So now ideal gas equation. Ideal gas equation क्या है भाई? So ideal gas equation is first is Boyle's law. Boyle's law is this one. N by P. Next is Charles' law. V by T, and Avogadro's law. Equal to N. So we take all this equation now and combine it, you get V N T P. So when you put equal to sign, we put R as constant. Just mug it up, R as constant, N by T P. So P goes this side, P multiplies it V, R, N, T. So this is called ideal gas equation. They ask you for 5 marks, I guess. Yeah, 5. So what is R now? I forgot to explain what is R. R is called universal gas constant. ये universal gas constant क्या होता है भाई? Okay, now universal gas constant is equal to R is equal to 8.314 joule Kelvin. So this 83.14 is constant throughout the universe. So this is called a universal gas constant. It does not change. So R is called universal gas constant. So they may twist this question and ask you, derive a combined gas equation. Now what is combined gas equation? Same, we write it as P1V1 divided by T1 equals P2V2 divided by T2. This is called combined gas equation. So just mug it up this part. So this is called a combined gas equation. And next is what Dalton's law of partial pressure. So they won't ask most of the time, but remember just keep in mind what is Dalton law. So on Dalton law of partial pressure, what that guy states is the total pressure exerted by a mixture of gas is equal to sum of partial pressure of all gases at constant temperature. Dalton explains the total pressure. So pressure exerted by a mixture of gas is equal to pressure of all gases, that is P equals to how many gas it may be, P1, P2, P3. So he explained that pressure will be equal. Okay, pressure on a reacting gas will be equal at a constant temperature. So pressure of all gases will be constant. So just keep in it, they won't ask you Dalton's law of partial pressure, only that what I explained, A, B and C, these 3 laws are important, and how to derive them. An ideal gas equation comes like 5 markers. So if they give you numericals from, keep in mind all these laws and all these equations, and ideal gas equation and combined gas equation. So next going kinetic molecular theory of gases. So what is kinetic molecular theory of gases? Is nothing. They are same like characteristics of gases only, but we have to define it. Kinetic molecular theory of gas. They ask you any 3 to 4 postulates. Um, so what are gas? Gases are made up of small particles called molecules. Gases are made up of small particles called molecules. So next is collision of gas molecules with the container exert pressure. What is the meaning of that? So जब गैस मॉलिक्यूल्स इधर उधर घूमता है तो कंटेनर के साथ जब झगड़ा करता है वो प्रेशर डेवलप करता है. So collision develops pressure. So collision is elastic. When they fight with the walls of the container, there is no loss of heat. There is no loss of heat or energy due to friction. Due to friction. And what are gases? Gases move freely, so they don't have intermolecular forces between them. So there is no intermolecular forces between gas molecule. So they ask you only 3 to 4 points in examination. So remember this easy ones. Don't go and break your head in learning big ones. So next is what is real gas? Real gas. I said you before only what is a real gas. A gas that does not obey ABC laws. ABC is what? Avogadro's law, Boyle's law and Charles' law. That is called real gas. Next is difference between ideal gas and real gas. They asked you only 3 points in this. Last time also we got this for 3 points. So make a column ideal gas, real gas. So same only. Gas that obeys Avogadro's law, Boyle's law and Charles' law. This does not obey anything. Does not obey any laws. Then ideal gas equation is PV equals RNT. So this has no equation. No equation This cannot be liquefied. Cannot be liquefied. And real gas can be liquefied. So next is a liquefaction of gases. In liquefaction of gases, liquefaction of gases, there are three things. What are they? Critical temperature, critical pressure, and critical volume. What is critical? What is that meaning? I'll explain you. So now what is critical? Critical is what point where you can't do anything. That's called critical. Like when you get a pain in your neck or in your joint, you scream out loud at a point where you can't tolerate that pain. That is called critical. So same thing in gases also. There is a point in which you can't liquefy pressure or temperature. That's called critical temperature. So what is first critical temperature? Temperature. What is it? The temperature above which gas cannot be liquefied by applying pressure. So that's called critical temperature. Now what is pressure? Critical pressure. So critical pressure. Critical pressure is minimum pressure required to liquefy a gas at a critical temperature. That's called a pressure. The minimum pressure required to cause liquefaction of gas at constant temperature. At critical temperature. We don't use constant, so critical temperature. What is critical volume? So volume occupied by a gas at a constant temperature. So we say it as volume occupied by 1 mole of gas at a critical temperature, and pressure is called critical volume. So what is critical volume? Volume, it is the volume occupied by 1 mole of gas at critical temperature and pressure. So till here is the portion for supplementary exam. So this is an easy chapter. Just you have to learn the theory part. That's it, and some sums. So again, I'm saying laws A, B, and C. Avogadro, Boyle's, and Charles' law. They'll ask you any one of this law and prove it mathematically. So I have to write the equation. This is laws. So this comes for like last time it came for like 3 markers, I think. Yeah, 3, and then they ask you some sums or their work problems. Yeah, problem. This comes for like 5 marks. Last time it came for 5 markers. Then what is that? Um, characteristics of gas there. I think 2 markers. Then kinetic postulates of gas.